we're going to take a look at the converse of the Pythagorean theorem and then some derivatives of it. So I think everyone knows what the Pythagorean theorem is. I mean, we've seen this for a long time. But just to kind of recap real quick, it says that, so if I have, I'm starting off poorly. If I have a triangle, and it is a right triangle, and I label my two shorter sides as A and B, and then my longer side, my hypotenuse, as C, the one that's across my right angle, then something has to be true. This is what is true. So it starts off with, if I have a right triangle, then it'll be the case that my two legs, if I square each of them and add them together, I will get my hypotenuse squared. So this will be the case for any right triangle whatsoever. And so this is my Pythagorean theorem. The converse then, of course, goes the other direction. It says, well, if I have a triangle, and I don't know that it's right yet, but if it's the case that if I take two of the sides and square both of them and add them together, and they equal the third side squared, then it'll be the case that triangle is a right triangle, with the hypotenuse being the side that is across from the longest side. So the converse is pretty straightforward. Now we can prove that a triangle is right using the side lengths. But it also opens up this whole other question here. We actually really have kind of three cases that's going on. Obviously, if I have my two sides squared, add them together, and they are equal to the third side squared, I get a right triangle. But what happens if instead my two sides, if I square them and add them together, they are less than the third side squared? And then on the opposite side of this, what happens if I add my two shorter sides again? I add them together, square them, then add them together, and they are greater than my my third side squared. So what do these mean, and what's going on here? Well, let's take a look at these examples. So let's start with the first one. So a squared plus b squared is less than c squared. So what does that mean about my triangle? Well, if I have a right triangle, so actually let me just redraw that right triangle here. So if I have a right triangle, poorly drawn, but you get the idea. All right, and I am going to take, so what this is saying is that my c squared, my longest side, is greater than what it should be to make a right triangle. So in other words, I'm keeping these two sides the same, let's say, and then I'm making this third side longer than what it should be to be a right triangle. Then what is the case? Well, this triangle now becomes obtuse. So this is the way that I always think of it, is that if this was the case, if a squared plus b squared was exactly equal to c squared, I get a right triangle. But if c squared, this longest side, and c will always be my longest side here, if it is larger than what it should be to be a right triangle, this will make an obtuse triangle. Then, on the other side of things, I could take a look at this again. If I have a right triangle one more time, but this time I'm taking my third side, my longest side, and I am making it shorter than what it should be. So say I keep this side the same, I make this one shorter than what it should be. So let's do this. Then what happens is that this triangle now becomes acute, because my third side here is shorter than what it should be to make a right triangle. Now, something that I just want to emphasize really quick is that, again, C in all of these cases has to be the longest side. Obviously, it's the longest side in a right triangle, because there's no way I can take two side lengths, one of which is larger than C, add them together and get something that's smaller. That just doesn't make sense. So C has to be a larger side here. Obviously, C is the largest side here because it's also greater. It's not just equal to, it's greater than the squares of these two sides. But then over here is the issue is I just have to make sure that I am making sure that C is the longest side, because you can see in this situation that if I continue to make this side smaller than what it is currently, then all of a sudden this angle is going to become my right angle potentially. So I just have to be really cautious about that. I always have to keep track of which side C is. It's got to be my longest side. So only one of these is my converse of Pythagorean theorem. It's this one here, that if a squared plus b squared is exactly equal to c squared, then I have a right triangle. But these derivatives is just kind of telling us, well, what are the other cases? What if c, the longest side, is too big to fit the Pythagorean theorem here, the converse of Pythagorean theorem here? Well, what I get is an obtuse triangle. And what happens if it is too small? And the answer is I get an acute triangle. So just by knowing the three side lengths of a triangle, I can always determine whether or not that triangle is acute, obtuse, or right based on how it fits into this kind of Pythagorean theorem idea here, where squaring the two shorter sides and adding them together and then comparing them relative to the third side, the longest side. Now, one other thing that I want to keep in mind, because these are the big takeaways, is that I should also, of course, always be checking to make sure that I'm making a triangle in the first place. I can continue to expand C in this situation here to make an obtuse triangle, but there will become a point where C can get too big and I no longer make a triangle. Or in this case, C can become too small before it's the side that I care about anymore. And I could potentially not make a triangle over here as well. So these are the big takeaways. I can determine what type of triangle it is, but I should also be wary of the fact that I might not be making a triangle at all, and I just have to pay attention to that. So that is kind of the converse of the Pythagorean theorem, and then with some additions. But now we can use these facts to determine what type of triangles I am working with.